We think of black holes as the ultimate cosmic outlaws, right? They devour light, they warp time, they break all the rules. But what if I told you there's one cosmic law that even a black hole can't escape? A universal speed limit. So let's really get into that. What does happen when you take the universe's most extreme object and spin it too fast? And look, this isn't just some sci-fi thought experiment. The answer is buried deep inside Einstein's theory of general relativity, and it tells us exactly what happens when you push the universe's ultimate spinning top just a little too far. So yeah, it's true that black holes can spin at these absolutely mind-boggling speeds, but there is a fundamental cosmic law that puts a cap on it. And we're not talking about a speed limit for moving through space. No. This is a limit on how much a black hole can physically twist the very fabric of space-time itself. And this isn't just some convenient theory. It's a core prediction of Einstein's general relativity. The exact same equations that perfectly describe gravity and why starlight bends, well, they also tell us that there is a hard stop, an absolute non-negotiable upper limit to how fast a black hole can spin. Okay, to really wrap our heads around this limit, we need to zoom in on a specific type of black hole, the Kerr black hole. This is our spinning model, and trust me, it's way more complex and dynamic than its simpler, non-spinning cousin, the Schwarzschild black hole. Here's a great way to picture this. A non-spinning black hole that's a Schwarzschild black hole is like a perfect sphere, a soccer ball, simple. But when it starts to spin, it becomes a Kerr black hole, and that rotation causes it to bulge out at its equator. It literally squishes, becoming more like a football. And that change in shape, that's our first big clue that the spin is fundamentally changing the object itself. And that powerful spin creates something absolutely wild, the ergosphere. This is a whole region outside the event horizon where space-time itself is being dragged around like water in a whirlpool. Inside this ergosphere, it is physically, literally impossible to stand still. Everything, even light, is forced to spin along with the black hole.
But here's the kicker. This spin doesn't just warp the space around the black hole. Oh no, it changes the black hole itself. More specifically, it actually shrinks the event horizon, that ultimate point of no return.
Which brings us to the cosmic rules of the road. In the language of physics, it looks like this. A divided by m has to be less than or equal to 1. A is just its spin, and m is its mass. That simple ratio, that's it. That's the non-negotiable speed limit for every single black hole in the entire universe. So what's the actual consequence of this rule? Well, this chart shows it perfectly. A black hole with zero spin has an event horizon of a certain size. But as you crank up its spin to the absolute maximum, where A equals m, the radius of that event horizon shrinks by exactly half. The point of no return literally gets smaller the faster it spins. Now to make that real, just think about a black hole with the same mass as our sun. If it wasn't spinning, its event horizon would have a radius of about 3 kilometers. But if you spin that same black hole to its maximum possible speed, its event horizon shrinks down to just 1.5 kilometers. Same mass, half the size. That's just wild. Okay, so every black hole has to obey this rule. But, you knew this was coming, what if it didn't? What happens if you could somehow break this cosmic speed limit and push a black hole past that boundary, where its spin is greater than its mass? Well, the fallout isn't just a little weird, it would be catastrophic for physics as we know it. It turns out the universe has a built-in safety mechanism, a cosmic failsafe, to stop this from ever happening.
The physicist Kip Thorne gave the most perfect analogy for this. He said that if a black hole spun too fast, centrifugal forces would tear its horizon apart, much like they fling water out of a bucket when the bucket spins extremely rapidly. The event horizon would just be ripped apart and flung away into nothing.
And the math of general relativity is totally unforgiving about this. If that spin-to-mass ratio, A over m, goes even a tiny bit above 1, the equation that defines the event horizon just breaks. It gives you an imaginary number, which in physics is basically the math screaming, nope, this can't exist in reality. The event horizon would simply cease to be. It would vanish. So what are you left with if the event horizon is gone? You get this terrifying thing called a naked singularity. That's the infinitely dense point at the center of the black hole, now completely exposed to the rest of the universe. And this is forbidden by a key idea called the cosmic censorship conjecture, which basically states that all singularities have to be clothed by an event horizon, safely hidden away from us. And that is the real catastrophe here. At a singularity, our entire understanding of cause and effect, of predictability, it all just goes out the window. An exposed singularity could, in theory, just spew out random information, completely violating the fundamental laws that make our universe orderly and understandable. All right, so the universe has this ultimate fail-safe to prevent the laws of physics from imploding. But this whole story isn't just about avoiding disaster. Pushing a black hole right up to its speed limit, well, that unlocks one of the most powerful engines in the entire cosmos. And this right here is why all of this really matters. That unbelievable amount of rotational energy stored in a black hole spinning at its absolute limit is the engine that drives some of the most powerful and spectacular fireworks in the entire universe. The way this happens is called the Blandford-Snark process. It's a pretty complex name for an amazing idea, a way to tap into the pure rotational energy of the black hole's spin and convert it into raw, incredible power. So here's how it works in 3 steps. First, the black hole spins, dragging space-time along with it. Second, this cosmic whirlpool grabs onto magnetic field lines from the stuff falling in and twists them up like giant rubber bands. And finally, the tension in these twisted magnetic fields gets so immense that they snap, launching these incredible jets of energy and matter away from the black hole at nearly the speed of light. And get this isn't just some cool theory on a whiteboard. We can actually see this happening. These are the colossal jets of a quasar, powered entirely by the spin of a supermassive black hole. These beams of energy can stretch for millions of light years. I mean, they dwarf the very galaxy that hosts them. It's unbelievable. This whole process is what creates quasars, the most luminous objects in the entire known universe. A single quasar, driven by the spin of its central black hole, can be thousands of times brighter than its entire host galaxy, a galaxy filled with billions of stars, all from spin. So think about it. A black hole's spin is held in check by a speed limit that literally protects the laws of physics. But at the same time, pushing right up against that limit creates the most powerful engines in the cosmos. Which kind of leaves us with one final incredible thought. If this force is powerful enough to create the brightest objects we can see, what other, more subtle things is it doing to the evolution and the very fabric of our universe?